Find the first 5 terms of the following sequences whose nth terms are given. Tn is equal to n square minus 2n. Here it is given that Tn is equal to n square minus 2n. For n is equal to 1, T1 is equal to 1 square minus 2 into 1, which is equal to minus 1. For n is equal to 2, T2 is equal to 2 square minus 2 into 2, which is equal to 0. For n is equal to 3, T3 is equal to 3 square minus 2 into 3, which is equal to 3. For n is equal to 4, T4 is equal to 4 square minus 2 into 4, which is equal to 8. And for n is equal to 5, T5 is equal to 5 square minus 2 into 5, which is equal to 15. Thus, the first 5 terms of the sequence are minus 1, 0, 3, 8, and 15. For each sequence, find the next 4 terms: 2, 6, 12, 20, 30, and so on. Here, T1 is equal to 2, T2 is equal to 6, T3 is equal to 12, T4 is equal to 20, T5 is equal to 30, and so on. If you observe all the terms carefully, you will notice that T1 is equal to 1 square plus 1, T2 is equal to 2 square plus 2, T3 is equal to 3 square plus 3, T4 is equal to 4 square plus 4, T5 is equal to 5 square plus 5. Using the same relation, we can find the next 4 terms. Therefore, T6 is equal to 6 square plus 6 is equal to 36 plus 6, which is equal to 42. Similarly, T7 is equal to 7 square plus 7 is equal to 49 plus 7, which is equal to 56. T8 is equal to 8 square plus 8 is equal to 64 plus 8, which is equal to 72. And T9 is equal to 9 square plus 9 is equal to 81 plus 9, which is equal to 90. Therefore, the next 4 terms are 42, 56, 72, and 90. Which of the following list of numbers are arithmetic progression? Justify. 3, 5, 7, 9, 11, and so on. Here, 5 minus 3 is equal to 2. That is, T2 minus T1 is equal to 2. Similarly, 7 minus 5 is equal to 2. That is, T3 minus T2 is equal to 2. Further, 9 minus 7 is equal to 2. That is, T4 minus T3 is equal to 2. Also, 11 minus 9 is equal to 2. That is, T5 minus T4 is equal to 2. This shows that the difference between any two consecutive terms is constant. Hence, the given sequence is an arithmetic progression. Zero point 0.5, 2, 3.5, 5, and so on. Solution. Here, 2 minus 0.5 is equal to 1.5. That is, T2 minus T1 is equal to 1.5. Similarly, 3.5 minus 2 is equal to 1.5. That is, T3 minus T2 is equal to 1.5. Also, 5 minus 3.5 is equal to 1.5. That is, T4 minus T3 is equal to 1.5. Thus, the difference between two consecutive terms is constant. Hence, the given sequence is an arithmetic progression. Write the first 5 terms of the following arithmetic progressions when the common difference d and the first term a are given. Number 1. A is equal to 2 and d is equal to 2.5. Solution. It is given that a is equal to 2 and d is equal to 2.5. Hence, T1 is equal to 2. Therefore, T2 is equal to T1 plus D. That is, T2 is equal to 2 plus 2.5, which is equal to 4.5. Now T3 is equal to T2 plus D. That is, T3 is equal to 4.5 plus 2.5, which is equal to 7. T4 is equal to T3 plus D. That is, T4 is equal to 7 plus 2.5, which is equal to 9.5. And T5 is equal to T4 plus D. That is, T5 is equal to 9.5 plus 2.5, which is equal to 12. Thus, the first 5 terms of an arithmetic progression are 2, 4.5, 7, 9.5, and 12. For an arithmetic progression, if T4 is equal to 12 and D is equal to minus 10, then find its general term. Solution. It is given that T4 is equal to 12 and D is equal to minus 10. Also, we know that Tn is equal to A plus n minus 1 into D. Therefore, T4 is equal to A plus 4 minus 1 into minus 10. As T4 is 12, therefore 12 is equal to A minus 30. Therefore 12 plus 30 is equal to A. Therefore A is equal to 42. Its general term, that is Tn, is equal to A plus n minus 1 into D. Putting the values of A and D, we get Tn is equal to 42 plus n minus 1 into minus 10. Therefore, Tn is equal to 42 minus 10n plus 10. Therefore, Tn is equal to minus 10n plus 52.
Given the following sequence, determine whether it is arithmetic or not. If it is an arithmetic progression, find its general term. The sequence is minus 5, 2, 9, 16, 23, 30 and so on. Solution. The given sequence is minus 5, 2, 9, 16, 23, 30 and so on. Accordingly, we have T1 is equal to minus 5, T2 is equal to 2, T3 is equal to 9, T4 is equal to 16, T5 is equal to 23, T6 is equal to 30 and so on. Now, 2 minus 5 is equal to 7. That is, T2 minus T1 is equal to 7. Similarly, 9 minus 2 is equal to 7. That is, T3 minus T2 is equal to 7. Also, 16 minus 9 is equal to 7. That is, T4 minus T3 is equal to 7. Further, 23 minus 16 is equal to 7. That is, T5 minus T4 is equal to 7. And 30 minus 23 is equal to 7. That is, T6 minus T5 is equal to 7. Thus, the difference between the two consecutive terms is constant. Hence, the sequence is an arithmetic progression. Therefore, A is equal to minus 5 and D is equal to 7. Its general term is Tn is equal to A plus n minus 1 into D. Substituting the values of A and D, we get Tn is equal to minus 5 plus n minus 1 into 7. Therefore, Tn is equal to minus 5 plus 7n minus 7. Therefore, Tn is equal to 7n minus 12. Find the sum of the first n even natural numbers. Hence, find the sum of the first 20 even natural numbers. Solution. Here, the first n even natural numbers, A is equal to T1 is equal to 2 and D is equal to 2. We have Sn is equal to n upon 2 into 2a plus n minus 1 into 2. Therefore, Sn is equal to n upon 2 into 4 plus 2n minus 2. Sn is equal to n upon 2 into 2 plus 2n. Therefore, Sn is equal to n upon 2 into 2 in bracket 1 plus n. Therefore, Sn is equal to n into 1 plus n. Sn is equal to n plus n square. Now to find the sum of first 20 even natural numbers, S20 is equal to 20 plus 20 square, which is equal to 20 plus 400. Therefore, S20 is equal to 420. Therefore, the sum of first 20 even natural numbers is 420.